Welcome back to the deep dive where we slice through those dense blueprints. We want to extract the core architectural strategies so you can quickly internalize what really defines a secure, scalable system. Today, we are taking a deep dive into the world of foundational cloud design. We're specifically looking at the complex decisions, the ones underpinning a successful private cloud deployment. And we'll use the lens of VMware Cloud Foundation, or VCF, as our model. Now, our mission today isn't to just walk you through some manual, not at all. It's really to shortcut your understanding. We want to pull out the most critical design insights, think security, how systems scale when they inevitably hit limits, performance tuning, and crucially, managing those non-technical risks. The ones that often derail big projects. This is basically your rapid, structured masterclass in private cloud design thinking.
And that focus on the principles is so important. I mean, yes, VCF gives us the framework, but these underlying decisions, they apply universally to complex enterprise IT. We're really honing in on that critical plan and design phase. That's the moment, right, where architects define the guardrails, the quality standards, the fundamental structure. Getting these initial calls right, well, that's the difference between a truly resilient environment and one that's, frankly, always failing or just way too expensive to run.
Okay, let's unpack this then. Starting right at the beginning, setting the ground rules. Every successful project, it seems, starts not with the tech, but with defining the scope. We have to understand what limits us, what constraints we have, and what's the minimum quality bar we absolutely have to clear.
Exactly. Architects, they need to be expert translators, really. They take these statements from stakeholders, sometimes vague ones, and classify them properly. And this initial classification, it pretty much determines everything that follows. So consider a statement like this. The design must be completed within the next 3 months so that hardware can be ordered within the current budget cycle. Now, that isn't just a wish, is it? It's a hard deadline, comes straight from the finance calendar. We classify that statement as a constraint. Immediately, it limits your planning timeline, forces quicker decisions on vendors, maybe restricts how you allocate resources. Miss that constraint and, the project could essentially die right there.
Right. Constraints are those hard boundaries, the non-negotiables you just have to work within. They tell you when and with what resources you've got to build the system. Simple as that. But then you have the other kind of statements, the ones defining how well the system must function, especially around things like legal mandates or industry standards, like handling sensitive payment data.
Precisely. Take a requirement stating that all data processing workloads must comply with the payment card industry data security standard PCI DSS at all times. That clearly falls under the design quality of security. And what's really critical for you, the listener, to grasp is why PCI DSS is such a fundamental driver here. It's not just a checkbox. It defines incredibly strict rules for protecting cardholder data. We're talking network segregation, mandated access controls, full audit trails, mandatory logging, the works. So when an architect sees that requirement, they immediately know they aren't just building a platform. No, they're building a heavily audited, segregated environment where security controls have to be baked into the core design from day one. You can't just bolt them on later. It won't work.
Okay, so the budget cycle gives us the constraint, the when, and PCI DSS dictates the necessary security quality, the how well. Makes sense. Now that we've kind of defined those rules and boundaries, the next logical step has to be securing the actual content itself, right? And streamlining how we manage the whole resulting infrastructure. This is where we start getting into the actual structure, the build.
Yeah, let's start with content security. That's often a huge risk area, surprisingly overlooked sometimes. You mentioned, say, a financial firm. And they have this really strict policy. Every single image used for deploying virtual machines has to be digitally signed by a trusted authority before any dev team can even touch it. What they're mitigating there is something called template drift, or even, supply chain risk within their own IT.
Okay, and I know a lot of places try to handle that with manual checklists or approvals,
Right.
which is slow, right? And people make mistakes. So what's the architectural solution? The infrastructure level fix that enforces this automatically?
The design solution you need here is using the provider-managed content library type within vSphere. And the why behind this is actually incredibly elegant, really. This specific library type ensures that only the cloud provider that designated internal trusted authority can publish, scan, and digitally sign the VM templates. So if the development teams are restricted, architecturally, to only pulling templates from this specific signed library, well, the security policy is satisfied right there by the architecture itself, not by someone manually checking a box. It really helps eliminate that human error factor.
That makes perfect sense. The content library itself becomes the single source of truth and, crucially, trust. I like that. Okay, following that theme of trust, Let's shift to operational isolation. This is often totally non-negotiable for highly regulated users like government agencies. So consider a scenario. Two separate government agencies sharing the underlying VCF hardware, but they absolutely mandate strict isolation. Monitoring data, logging, even admin access must be totally separate. You simply cannot risk Agency A accidentally seeing Agency B's operational data.
Yeah, that requirement for absolute segregation, it's an operational tax, basically, that the design just has to absorb. You can't achieve that level of isolation by simply creating different folders or, using standard network segmentation. It's not enough. The necessary design decision here, the only real way to guarantee it, is to deploy two separate VCF operations instances, one dedicated entirely to each agency. And if we connect this to the bigger picture, this choice guarantees complete operational data isolation. By dedicating the entire management and monitoring plane, the sort of brains of the system, to each entity, you eliminate any possibility of cross-agency visibility. It satisfies those ultra-strict requirements. The cost, of course, is managing two management stacks instead of one. But the security payoff, it's usually deemed worth it in those scenarios.
That's a really interesting trade-off. Duplication for airtight security. Okay, now let's look at the flip side, management simplification. Architects are always looking for ways to reduce that management overhead. Right. So if an architect decides to place two distinct vSphere clusters inside a single vSI workload domain, what's the big operational win there?
Okay, first, just for clarity for the listener, a VI workload domain. Think of it as a pre-validated, organized collection of resources managed together as a unit. Now, when you put two or more clusters inside that single domain, the key implication is, well, it's massive operationally. It directly reduces the number of vCenter server instances you have to deploy and manage.
Wait, hold on. Why not just keep them separate? What are the real implications of centralizing like that?
Because all the clusters within that one VI workload domain share the same vCenter server. And vCenter, that's your central control panel for vSphere, right? So managing fewer of them means fewer updates, fewer certificates to worry about, fewer systems to patch and maintain overall. It's a fundamental decision for centralizing the management plane and cutting down on that day-to-day operational complexity. Now, there is a potential downside, which an architect always has to weigh. You do increase the shared failure domains slightly, and you risk contention if those clusters are managing wildly different workload types. But for similar workloads, the management simplicity you gain is often a huge win.
Okay, got it. So security and administrative simplification are critical foundations. But let's be honest, nobody wants to use a super secure infrastructure that's painfully slow. So let's pivot hard now to performance. The infrastructure has got to be fast, and it needs to be able to grow without hitting roadblocks.
Couldn't agree more. I mean, consider mission-critical databases. These are your absolute highest tier of application, right? They demand the maximum possible IOPS and the lowest possible latency. And IOPS, just for anyone unfamiliar, that's input-output operations per second. Basically, how fast your storage can read and write data. It's often the ultimate test of your storage layer's capability.
Right. So in a modern VCF environment facing these ultra-demanding databases, what's the best design call? Especially if we want flexibility and control, not just brute force.
The answer really is almost always to implement vSAN with tiered storage policies. It's a very elegant solution. See, instead of just throwing the most expensive hardware at the entire problem, vSAN lets you define policies. You can leverage your highest performance devices, maybe all flash, maybe NVMe, to create specialized high-performance tiers within the vSAN cluster itself. And the beauty of it is storage policy-based management, or SPBM. You use that to assign those specific high-performance policies only to those demanding mission-critical workloads. Everything else, it can sit quite happily on a lower cost, maybe lower performance tier. This ensures the databases get dedicated high-speed lanes without forcing you to build the entire infrastructure at that maximum cost and complexity. It's smart.
That really is performance engineering right at the policy level. Yeah. Much more efficient, I imagine, than carving up traditional LUNs and all that. Okay, speaking of efficiency and growth, systems have to scale horizontally, right? Grow outwards. So what happens when a workload domain, which, as you said, might contain several clusters, starts nearing its maximum host limit? Maybe it's capped by the existing vCenter server it uses. You've hit the physical limit of that central control plane, but you still need more capacity. What then?
Yes. This is a classic scalability challenge in VCF environments, and it's exactly why the workload domain construct is so powerful. You can't just keep adding hosts indefinitely to a single vCenter instance. There are architecture limits. So when you hit that cap, the most appropriate, the standard design decision is to deploy a second workload domain within your existing VCF instance. If you look at how VCF workload domain scalability works, you realize this is the governed, structured way to grow. Each new workload domain you deploy brings its own dedicated vCenter server instance along with it that immediately lifts the host count limitation imposed by the original vCenter. So you scale your opacity potentially dramatically, you manage the complexity by using these standardized domain building blocks, and you keep everything neatly under the centralized management umbrella of the overall VCF environment, the SDDC manager.
That's a really crucial distinction there. It's scaling by duplicating the control mechanism, but in an organized, parallel way, not just trying to cram more and more compute under one stressed-out controller. Okay, so we've built a system that's secure, it's simplified administratively, it's performant, and it's scalable. The final critical pieces of the puzzle involve resilience protecting this powerful blueprint from, say, physical site failures, and, maybe even more importantly, from those internal human risks. Let's tackle physical failure first. Imagine we have a customer, they've got two physically separate data centers. Maybe they're about 10 miles apart. Now that distance usually equates to roughly 10 milliseconds of network latency, give or take. And the requirement is absolute. Shared storage data must be 100% current and available instantaneously if one site fails completely. That 10 millisecond figure tells us we have to use synchronous replication, doesn't it?
Yes, absolutely. That 10 millisecond round-trip time threshold is critical because synchronous replication, meaning data has to be written successfully to both sites before the write operation is acknowledged back to the application, can only reliably function under very low latency conditions. If you go much higher than that, applications start to experience unacceptable delays, performance tanks. It just doesn't work well. So to guarantee that 100% current continuous availability across sites with that latency profile, the source materials really point to two specific storage technologies. The first, and perhaps most integrated, is a vSAN stretched cluster. It's purpose-built within VCF to synchronously mirror the entire storage layer across two geographical sites.
Okay, integrated. And what's the second option?
The second valid option is using vSphere virtual volumes, or vVols, but in conjunction with array-based replication. So if the underlying storage array itself supports synchronous mirroring between the sites, vVols allows the architect to manage that powerful array capability, but with the same kind of policy-driven granularity we talked about earlier with vSAN, makes it much easier to manage at the VM level. But in both cases, the key enabling technology, the non-negotiable part, is that guaranteed synchronous replication. That's what meets the requirement.
Fantastic. Two solid options there. Now let's quickly switch back to the operational management layer, VCF operations, the monitoring and alerting system. If our requirement is to minimize monitoring and alerting downtime across the entire VCF fleet because, you can't afford the brain of the operation to go offline, how do we design for that?
Absolutely critical. The monitoring and alerting system itself needs its own internal fault tolerance. Can't be a single point of failure. So the supporting design decision here is definitely to deploy VCF operations using the high availability model, typically implemented with collector nodes. You can kind of think of the collector nodes as the distributed sensors gathering data across the environment, and the high availability model ensures you have a redundant brain or analytics cluster. This configuration provides inherent fault tolerance. If one management component fails, the others immediately take over its workload. It ensures you have continuous visibility and alerting across the entire fleet. Because honestly, downtime for visibility is almost as bad as downtime for the applications themselves in a production environment.
Very true. Okay, let's end on what I think is often the most overlooked architectural failure point, the human element. An architect builds this beautiful, complex VCF infrastructure. Everything's resilient, performant. But they make a faulty assumption that the current IT staff actually has the necessary skills to operate it effectively. Then reality hits, and that assumption proves false. This is a massive, potentially project-killing operational risk, isn't it?
Oh, it is the silent killer of so many enterprise projects. You can have the most resilient, perfectly engineered infrastructure on paper, but if the staff can't patch it correctly, scale it when needed, or troubleshoot it effectively when things go wrong,
Right.
the system fails in practice. We see this play out all the time.
So given that stark reality, what is the single most critical risk mitigation strategy the architect absolutely must factor into the plan and budget from the start?
The key strategy, and this is really important, it's usually not trying to outsource everything long term or attempting to hire an entirely new specialized team overnight. Both of those are expensive and fraught with their own risks. No, the most effective approach is usually to proactively allocate dedicated time and, crucially, budget to train the existing support staff on the new skills required specifically for VCF operations and management. Targeted, internal training. It's the most effective way to build sustainable institutional expertise. It empowers your existing workforce, it ensures proper long-term operation of the platform, and honestly, it provides a much better ROI in the long run than simply relying on external consultants for every single operational task forever. It really proves that architectural design isn't just about hardware and software specs, it's fundamentally about enabling the people who have to run it day in and day out.
Well, thank you for joining us on this deep dive into the VCF Architect Blueprint. Really insightful stuff.
My pleasure. Until next time.
Happy diving, everyone.